All right, hello once again. This is Jeff Scott of Rankin Technical College, and I've been working my way through the online PDF textbook AppInventor2 Create Your Own Android Apps by Wolber, Abelson, Spertus, and Looney. And we have gone through everything in the tutorial section, and we've gone through much of the Inventor section, but it's time for the last, I think, 4 chapters now. So let's jump into Chapter 21, Defining Procedures. And remember, when you define a procedure, we're talking about user-defined procedures, not the ones that are built into App Inventor. All right? With that said, notice what it says. Programming languages such as App Inventor provide a base set of built-in functionality. Well, you've done things like, for example, when you've had a button, all right, you put something in the button's click event, for example. In App Inventor, though, you can define your own procedures. The author defines those as named sequences of blocks that your app can call just as it calls App Inventor's predefined blocks. As you'll see in this chapter, being able to create such abstractions is very important for solving complex problems, which is the cornerstone of building truly compelling apps. Well, the idea is this. If you were told when you click a button that you want 8 actions to happen, you could probably put all 8 of those actions inside of the button's click event. But pretty soon the button's click event gets so unwieldy as far as length that it gets very confusing. But if you take each one of those 8 actions and put them into their own procedure and call those 8 procedures, it's much easier to work with. Plus, what you're doing when you do that, when they talk about abstraction, is you are taking a problem and you are breaking it down into a series of subproblems, and you're solving those subproblems individually. So if you have a problem with any of those subproblems, no pun intended, it's much easier to work on a subproblem at a time. Now, they mention when your parents tell a child, go brush your teeth before bed, what they mean is to go into the bathroom, take out your toothbrush, maybe put some water on it, put the toothpaste on it, put some more water on it, etc. But the kid knows what they mean. It's been abstracted. We live our lives as a series of abstractions. All right? When somebody says, if you've got a child and your child calls you up and says, hey, pick me up from soccer practice, they don't say, hey, if you're in the living room, get up, go into the kitchen, grab your car keys, go outside and unlock the car, etc. Okay? So in programming, as it says, we take and name sequences of instructions. Some programming languages call them functions, some call them subprograms, some call them methods. All right, in App Inventor, they're referred to as procedures. And again, as mentioned earlier, a procedure is a named sequence of blocks that you can call from any place in the app. So this would be an example here. And what they say here is this estimates the distance in miles between any 2 GPS coordinates you send it. So if you were taking a trip and you wanted to know, let's say that you were taking a trip from St. Louis, Missouri to Chicago, Illinois. And you wanted to go, and you wanted to know how far it was from St. Louis to maybe to the Illinois border. All right, you could do that as far as the distance between 2 points. Then you could call it again. Maybe you wanted to see how far it was between the border and, some other city in Illinois that was partway there, type of thing. But this is a general routine that was written. And notice there's nothing in here. You've got the 69-1. Don't worry about that. But we've got get x and get y, get latitude and get longitude. All right, of your 2 points. So the idea is it's written in a generic enough way that you can call it several places along the way. And the author says, don't worry about the internals of this procedure right now. Just realize that it allows you to basically extend what you're able to do in a program. After you define the procedure, you can ignore the details of how it works. I don't know internally what happens when I click a button. I know that it calls the button's click event in here, but I'm not sure exactly internally what happens, and I don't have to care. That level of detail has been abstracted away from me. And as it says, this type of abstraction is key to solving large problems and lets us break down a large project into more manageable chunks. Also, it eliminates redundancy. We don't have to write the same code over and over again. We can take the code, put it in one place, and then call it from whatever places we need to call it from. So a procedure, as mentioned here, lets you encapsulate blocks in one place and then call them, I wouldn't even say many times, but you can call them on an as-needed basis. All right? They allowed you also to build up a library of code that can be reused in many apps. Now, one thing about that, I haven't done very much with that because, to my knowledge, that's very limited right now as far as what you can do with a code library in AppInventor. All right, so the eliminating redundancy says the blocks here in Figure 21.2 are from a note-taker app. Take a look at the blocks and see if you can define the redundant ones. Well, if you look in here, setting this, all right, got a for each item, setting text, looks a lot like what we're doing in here, looks a lot like what we're doing in here. So as it says, the redundant blocks are the ones involving a for each block. Actually, the for each and its nested blocks. In all three instances, the block's job is to display a list of notes. In this app, the behavior needs to take place in 3 event handlers. Then they mentioned on the bottom of the page and going on to the next page here. When an experienced programmer sees such redundancy, it sends off a signal that, hey, it's best to encapsulate that redundancy in a procedure and call it on an as-needed basis. All right, it says, accordingly, an experienced programmer would create a procedure, move it to a redundant block, etc. The app won't behave any differently, but it will be easier to maintain and for other people and other programmers to work with. When you do this, when you encapsulate the functionality, when you eliminate redundant code, and your program works the same way that it did to begin with, that's called refactoring. All right? So it says, let's build a procedure to do the job of the redundant code blocks in Figure 21.2. In AppInventor, you define a procedure like you do a variable, but you go to the procedures drawer. Now, the key thing to realize is these two things right here. All right? It says after you drag out a procedure, you can change its name. Well, this is the first one. This procedure will not return anything. So in other languages, it's known as a void procedure. All right? So we drag this out, we change its name, and then we put in the code within it. And it's even possible, depending on the complexity that you get in a procedure, that you'll have to write a procedure that calls yet another procedure. As we've seen also in earlier chapters, it's also possible for a procedure to call itself, all right, which is known as a recursive procedure. So it says procedures are entities with the potential to perform a task. However, they'll only perform that task if they're called to do so. When you add a procedure, a call block for that procedure is automatically added. We've used call blocks throughout these entire lectures to call AppInventor's predefined functions. For the note taker example, it says you'll call out 3 display list blocks and use them. All right? And there's the call to display list. Anytime you are either repeating code, or if you as a developer think there's a chance in the future you will be repeating code, you should always take that as an opportunity to create one or more associated procedures to, again, encapsulate the logic. All right, they explain how this works, but we've gone through it already, so I don't think there really is a need to go any further with that. It says here the display list procedure has limits as far as its general usefulness. It only works for a specific list. So again, the idea is what you'd like to do is you would like to write it in a way that it would be generic and you could use it in a lot of different routines and ideally in a lot of different apps. So one thing you may want to consider, as it says, because AppInventor, like most other programming languages, provides something for you that are referred to as parameters. And that's information that can be provided, all right, and it can be provided to the procedure. It's as though, you're giving an example similar to the one that was discussed before with brushing your teeth. You know, you are a little kid and your room is all messy, and you get home and your parents say, clean the room. And you know, maybe you're a little smart aleck and you go, what room? Clean the room, I mean the bathroom. Clean the room, I mean your room. The bathroom or your room would be examples of parameters. They're information that the procedure needs in order to get its stuff done. And that's what they talk about in here. So they've written a more display, you know, they want to display a list, but now they're passing into that procedure a list. So you can basically have it display any list. There you go. Again, as I mentioned earlier, now I think they're going to show it, it is possible to return a value from a procedure. So with this display data that we have, it can display any list of data, but it'll always display that data in the label notes label. If you wanted to display it someplace else, as mentioned here starting on the bottom of the page, one solution is to reconceptualize the procedure and change its job from displaying a list in a particular label to displaying it anywhere you want. To do this, you use a procedure result block. So before this was all right, to procedure do, but if you have, you know, if you have result, like we looked at the end, you are allowed to pass information back. All right? So now what they're saying is the result is get text. So that result will be passed back because maybe you don't always want to put the results in a label. All right? Maybe sometimes you want to put them someplace else. And here's an example. Now, for whatever reason, all right, you're setting the notes label, but you can also set a user list label. You could be setting something else. Reusing code through procedures need not be restricted to a single app. There are many procedures that could probably use this app. Now, this is an important point. If you look on the top of the page right here, it says typically programming languages provide an import utility through which you can include library code in any app. AppInventor does not yet include such a procedure. The only way to share procedures is to create a special library app and begin new app development by saving a copy of that library app and then working from it. So in this particular chapter, we went through it again fairly quickly. Programming languages such as AppInventor provide a base set of built-in functionality which you can extend by creating your own procedures. As it says here, the ability to define higher-level procedure blocks is the key to engineering large, maintainable software and solving complex problems without constantly being overwhelmed by the details. As we've seen in the chapter here, procedures let you encapsulate code blocks and the functionality and give them a name. When you program the procedure, you focus solely on the block details. However, in programming the rest of the app, you now have an abstraction that you can refer to at a higher level. That's it for Chapter 21. I'll come back with Chapter 22 to talk databases with you in just a couple minutes.